All right, starting lesson 5.4a, sum and difference formulas. Now, we'll be working a lot with the sum and difference formulas at the bottom left of your yellow sheet. All right, so be ready to use those. All right, now find the exact value of sine of 75 degrees. Okay, now, we haven't worked with triangles that have a 75-degree angle, okay? But what you could do is break 75 up into some sum or difference. Now we've worked with 30-degree angles, 60-degree, and 45. So can you break down 75 into some combination of those values? Yeah, you could break down 75 into 30 plus 45. All right, so now we're going to apply our sine sum formula. And so this is equivalent to sine of 30 times the cosine of 45 plus cosine of 30, I should say degrees, and sine of 45 degrees. Okay? And now all we have to do is construct triangles based on these angle measurements, and we could simplify this whole expression. So rotate 30 degrees. There's this triangle. Now I could label it 1, square root of 3, 2. Rotate 45 degrees. I have this triangle. 1, 1, square root of 2. Okay. Now this is a triangle for 30 degrees. This is the triangle for 45 degrees. Now just apply the trig functions based on those angle measurements. So sine of 30 is, let's label all these sides here. All right, so sine of 30 is 1 over 2. Then we have times cosine of 45, adjacent over hypotenuse. Let's look at this triangle over here to the right, and we have 1 over square root of 2. Then we have plus, and we have cosine of 30, which is adjacent over hypotenuse. And then we have sine of 45, which is opposite over hypotenuse. All right, simplifying this, we get, well, notice that we have a common denominator here. So I'm going to have 1 plus square root of 3 over 2 square root of 2. And I will rationalize the denominator. So multiply top and bottom by square root of 2. And I'm going to distribute. So I get square root of 2 plus square root of 6 over 2 times 2. All right, because multiplying these gives us 2. And I have square root of 2 plus square root of 6 over 4. All right, so just drawing on a lot of the previous knowledge that you've acquired and just applying this new formula now. Let's do another example. Find the exact value of cosine of pi over 12. All right, it may be easier to convert from radians into degrees. So I have 15 degrees here. All right, if you forgot how to do that, pi over 12 times 180 over pi. All right, that's all there is to it. Okay, so once again, I know how to work with these angle measurements. So can I break 15 up into some combination of these values, either as a sum or difference? Yeah, well, there's two possible combinations. You could do cosine of 45 minus 30. Or you could also do cosine of 60 minus 45. It doesn't matter which combination you come up with. You'll end up with the same result at the end anyways. Okay, so I'm going to work with the second one. All right, working with cosine of 60 minus 45. So using your formulas, be very careful using the cosine difference formula. And I have cosine of 60 degrees times cosine of 45 degrees plus sine of 60 degrees times sine of 45 degrees. All right, and creating my triangles here. Let's see, I have 60 degrees as my rotation, so that's 1, that's square root of 3, and that's 2. And then I have 45 degrees, 1, 1, square root of 2. All right, now opposite, adjacent, hypotenuse, opposite, adjacent, hypotenuse. Okay, so let's just come up with our ratios now. Cosine of 60 using the left triangle, I have adjacent over hypotenuse. Cosine of 45 using the triangle at the right, I have adjacent over hypotenuse. And using the triangle to the left, sine of 60, I have square root of 3 over 2. And using the triangle to the right, I have 1 over square root of 2. Once again, I have a common denominator, so I could rewrite this as 1 plus the square root of 3 over 2 square root of 2. Rationalize the denominator once again. Don't forget to distribute. And we get square root of 2 plus square root of 6, over 4. All right, that's all there is to it. On to the next example. All right, so for example 3, write the expression as a sine, cosine, and tangent of an angle. Okay, now looking at this craziness here, let's get familiar with your sum and difference formulas once again. Let's look at the sum and difference formulas for tangent. And you'll notice that it has this exact structure. Okay, so looking at your formula, your theta would be 140 degrees, and your beta would be 60 degrees. Okay, so this easily converts into this. Okay, just applying the formula. And then that simplifies to this. All right, and they're not asking you to find the exact value. They're just asking you to rewrite the expression as a sine, cosine, or tangent. This should actually say or, not and. Or tangent of an angle. So tangent of an angle. We're done. Find the exact value. Okay, what makes this one different from example 1 and 2 is that we're going backwards now. All right, you could think of it as example 1 and 2 as going forwards. For this one, we go backwards. So we're going to take this and condense it. So looking at your formulas now, be really careful. Let's see which one matches up. It's going to be sine, or is it sine? No. Let's see, we start off with cosine, cosine. So that means we're working with cosine. And we have theta, beta. All right, it's 25. And it's going to be plus 20. All right, be really careful based off the sign here. We work with the opposite here. And that's all there is to that. So it's going to be cosine of 45. And we could easily figure out the exact value of this. So 45 degree triangle. All right, and cosine is adjacent over hypotenuse. Rationalize the denominator. Done. So although these problems may look quite complicated at the beginning, once you understand your formulas, I can't emphasize this enough, once you understand all the formulas on your yellow sheet and when to apply them, these problems become very easy to solve. All right, example 5, find the exact value of cosine of 120. Now for this one, you don't have to break it up into numbers that we're used to working with, because look at this. If I rotate 120 degrees, then I end up with this triangle or the reference angle is 60 degrees, right? All right, and that's 30. So I have 1, square root of 3, or negative 1, and then 2. So now I have my adjacent, opposite, hypotenuse. I'm working with cosine, so I have adjacent over hypotenuse, and that's it. For your final answer, typically the negative is right next to the division symbol. So that's all there is to it. Okay, if you have any questions, please make sure to ask. Begin the assignment at the bottom of the page.